Hello and welcome to the lecture on projectile motion. In this video, we will take an example of a ball hitting a wall. In this example, a person hits a ball towards a wall at a speed of 25 meters per second and at an angle theta 0 equal to 40 degrees. The wall is 22 meters away from the release point of the ball. Thus, we have a wall and a person is hitting a ball towards the wall at a speed of 25 meters per second and making an angle of 40 degrees from the horizontal direction. The release point of the ball is 22 meters away from the wall. Once released, the ball moves like a projectile and hits the wall at a height h from its release point. So the ball hits the wall at a height h from its release point. Thus we are given that v0 equal to 25 meters per second, theta 0 equal to 40 degrees, distance of the release point of the ball to the wall is 22 meters. In this problem, we will assume that the x0 and y0 coordinates, that is the initial coordinates of the ball, are 0. In this problem, we are required to find the value of the h, that is we are required to find the height at which the ball hits the wall from this release point, and we are required to find the components of velocity just before hitting the wall. We are required to find the component of velocities of the ball just before hitting the wall. First, we will determine how far above the release point does the ball hit the wall. We can do this by using vertical equation of motion, but to do that, we need to know the time taken by the ball to hit the wall. The time taken by the ball to hit the wall can be obtained by using horizontal equation of motion. Now the horizontal equation of motion is x equal to v0 cos theta 0 t, and when the ball hits the wall, x is equal to d, therefore t is equal to v0 cos theta 0 t. And from this we can obtain time as d by v0 cos theta 0. Putting the values of d, v0 and theta 0, we obtain time as 22 by 25 cos 40, and if we calculate it, we'll find that t is equal to 1.15 seconds. Therefore the ball takes 1.15 seconds to hit the wall. Now, the vertical equation of motion is y equal to v0 sine theta 0 t minus half gt square, and when the ball hits the wall, y is equal to h. Therefore, h is equal to v0 sine theta 0 t minus half gt square. H is equal to v0 sine theta 0 t minus half gt square. Putting the values of v0, theta 0 and time which we have just obtained, we can obtain h as 25 sine 40 into 1.15 minus half 9.8 into 1.15 square. And if we calculate it, we will find that h is equal to 12 meters. Therefore, the ball hits the wall at a height 12 meters from its release point. Next, we will determine the components of the velocity when the ball hits the wall. We know that acceleration doesn't act in the x direction, therefore x component of the velocity doesn't change. Therefore, when the ball hits the wall, it has a x component of velocity which is equal to the initial x component of the velocity, and which is equal to v0 cos theta 0. Therefore, x component of the velocity is vx equal to 25 cos 40, and if we calculate it, we will find it that Vx is equal to 19.15 meters per second. Therefore, the x component of the velocity is 19.15 meters per second. Gravity acts in the y direction, therefore the y component of the velocity keeps on changing with time, and we find it by using Vy equal to V0y minus gt. V0y is V0 sine theta 0, therefore Vy is equal to V0 sine theta 0 minus gt. Putting the values of V0, theta 0 and t, we obtain Vy equal to 25 sine 40 minus 9.8 into 1.15. If we calculate it, we will find that Vy is equal to 4.8 meters per second. Therefore, when the ball hits the wall, it has a y component of velocity equal to 4.8 meters per second. We can calculate the magnitude of velocity as v equal to square root of vx square plus vy square, and if we calculate it, we will find that v is equal to 19.74 meters per second. Therefore, magnitude of velocity when the ball hits the wall is 19.74 meters per second. Now we can see that y component of the velocity when the ball hits the wall is positive. That means the ball was still going upwards when it hit the wall. This means that it has not reached its maximum height, and it is yet to reach its maximum height when it hit the ball. Therefore, this height that we have obtained h is not the maximum height of the ball. That's all for today. In the next video, we will study the uniform circular motion.